Hello my dear students, in this lecture we are going to see one previous year GATE numerical on gas turbine cycle. This question was asked in GATE 2020 on gas turbine. Now the question is, the compressor of gas turbine plant operating on an ideal intercooled Bryton cycle accomplishes an overall compression ratio of 6 in a two-stage compression process. Now here there is a intercooling. They are saying that there is a intercooling in a gas turbine. Let us draw temperature versus entropy diagram. On temperature versus entropy diagram, now the compression is in two stages because there is an intercooler is used, right? And therefore, my dear students, from 1 to 2 there is reversible adiabatic compression. Then from 2 to 3 the heat is rejected at constant pressure. This is called intercooling. 2 to 3 is called intercooling, and 3 to 4 again there is reversible adiabatic compression in compressor 2, right? Then from 4 to 5 there will be a constant pressure heat supply, right? 4 to 5 there will be a constant pressure heat supply. 5 to 6 there will be a reversible adiabatic expansion, and 6 to 1 there will be a constant pressure heat rejection. This is called intercooled gas turbine cycle. Now what they are saying, the compression is done in two stages, means from 1 to 2 there is a compressor, and 3 to 4 there is a compressor. And my dear students, here P2 is equal to P3 because it is intercooling is done at constant pressure. Then the overall compression ratio is 6. That means overall compression ratio means maximum pressure during compression is P4. Therefore minimum pressure during compression is P1 is equal to 6. This is the mentioned, right? Overall compression ratio is 6. Then in two-stage compression process, intercooling is used to cool the air coming out from the first stage to the inlet temperature of first stage before its entry to the second stage. The meaning of this is the intercooler is used to remove heat from the compressed gas of first stage, right? This is the purpose of intercooling. Then air enters the compressor at 300 Kelvin. Entry of compressor, that is T1, is equal to 300 Kelvin and 100 kilopascal. 100 kilopascal is pressure. Therefore P1 is equal to 100 kilopascal, right? This is given. Then if the properties of gas are constant, the intercooling pressure for minimum compression work in kilopascal is, now they are mentioning round off up to 2 decimal places. Now what is the meaning? Here they are asking intercooling pressure. Intercooling pressure is P2 or P3, right? Therefore what is the value of P2 or P3 for minimum compression work? For minimum compression work, right? So that work of compression will be minimum. Now my dear students, for minimum compression work, this intermediate pressure, that is P2 is equal to P3, is a geometric mean of minimum pressure and maximum pressure in the cycle, right? That already you have derived, also we have derived in the Bryton cycle. Therefore this P2 is equal to P3 is equal to under root of P1 P4. This is called the intermediate pressure for minimum work of compression. And if it is turbine, this the intermediate pressure is for maximum work of turbine. Turbine is a work producing device, therefore we will get maximum work for this condition, and for work consuming device we will consume minimum work, right? Therefore for compressor it will be having minimum work. So my dear students, to find P2 or P3 we need to calculate P1 and P4, and here P1 is given. So from pressure ratio, that is P4 divided by P1, which is nothing but 6. Let us find P4. Therefore P4 is equal to 6 into P1. P1 is nothing but 100. Therefore P4 is equal to 600 kilopascal. So my dear students, we have P4 value, we have P1 value. Let us find P2 or P3. Therefore P2 is equal to P3 is equal to P1 is 100 into P4 is 600. So if I simplify this, then the solution for this question will be 244.9 kilopascal, right? That means the answer of this question is 244.9 kilopascal. So here already they have mentioned the unit. So my dear students, there is no provision for typing the units, therefore we have to type here numerical value, that is here in this fill in the blanks 244.9. this value we have to type for getting full 2 marks. Thank you dear students. In next lecture we will see one more numerical on this topic.